Okay, I think we have to start. I want to continue where we ended last time, looking at the basic or the introduction to querying data using SQL Server. I did introduce the SQL Server Management Studio as a means by which you interact with the database engine and I did introduce you to some basic data types, particularly to do with numbers and text. So today I want to look at a bit more information about using the select statement and how you can use it to retrieve information. The select statement is a very important statement in the use of SQL Server. And most of the time you are going to use it for different activities to do with retrieving data. The syntax for SQL for select statement is given there. Select followed by these two words. Whenever I give you syntax where some terms appear inside square brackets, what that means is that those are optional items, like arguments, okay? And if you have more than one item in square brackets separated by the pipe symbol, this one, it means that you can choose one of those items. So when you're using select statement, you can either use the word or you can use the word distinct. And both of them are optional. And that should be followed by a list of columns that you want to retrieve from the database. Then there's also another optional command keyword, which is into. This one is used when you want to retrieve data from a table and enter it into another table. Then there's also the word keyword from, which is optional, where you specify the name of the table or the view from which you want to retrieve data. And lastly, you have the where clause, where this is where you indicate the condition for the search, okay? The example I have before you retrieves all, this one, retrieves all the information from a table called employees. Now you see that after the keyword from, there's the part which says human resources. This part, human resources, this part is the schema. A schema, in a nutshell, is a logical way of partitioning your database, okay? It's a a non-physical way in which you can apportion different objects, database objects, to different parts so that each of those portions can be maybe managed by different individuals. Normally, in a large organization, you are going to have different groups of people accessing the database. And so you can have people from human resources department, you can have people from financial and accounting department, you have people from maintenance and production, you have information from, you have employees maybe from sales and marketing. All those people can be grouped according to their needs, and you can create a schema for each of those groups so that you can give them rights and permissions to access parts of your database according to what is they need for them to carry out their day-to-day work. Okay, so in the sample database, we have schemas such as human resources, and within that schema, you have several tables. Okay, so the asterisk, like I mentioned last week, is used to indicate, is a substitute for the word or. That is, you want to retrieve all the columns from the specified table. Okay, so if I was, let me switch to my database. Please, if you have any questions, just ask. You just stop me and ask your question. So when I go to tables, you notice that AdventureWorks database has a number of different schema. So I have these. They are all for human resources. Then I have another schema called person. I have this schema called production. Production, most of it. Now, if you don't specify the schema when creating a table, SQL Server is going to assign it to the DB or schema. This is the default schema for SQL. So every time you create a database and when you're creating tables inside it, you don't specify the schema, they are going to be assigned to the default schema, which is DBO. Okay. Now, the idea is objects like tables in one schema are supposed to have a unique name, but you can have the same name of table as long as those tables are not in the same schema. They could be part of the same database, but if they are in different schema, the tables can have exact names. That's not a good practice, but it's something that you can do, okay? So I'll start new query. Now, the employee table, if I was to open it in a design view, so in a graphical view, you see that okay, so that's the information which is contained in this table. Okay, now when I want to see all these columns, I can use this command. First, I want to use the AdventureWorks database. Then I can say select star human resources dot employee Okay. So when I enter a command like this, it means that I'm going to see all the columns just like we have in this one. All the columns are going to be represented. Okay. So I'll go ahead and execute this. Okay. So it will retrieve all the columns. Okay, but this is rarely the case. In most instances, you want to retrieve only a selected number of columns which are relevant for that particular application. So to select only certain columns, you list them after the select statement. So I can say employee ID, comma, then maybe title, comma, and maybe date of birth, birth date, comma, and maybe marital status. Okay. All these are coming from a table called employee table. Okay. So when I do that, I'm specifying that in the output or the result, I only want to see the column for employee ID, title, date, birth date, and marital status. The other columns are not going to be displayed. So I'm going to only retrieve those columns which I've specified. And that is compared to what you get if you are to, so you see the one on top is showing us all the columns from the table, and the one below is showing us, that's the result set, showing us only the selected columns. All the rows are going to be included because I've not set any condition. So if you check here, we have retrieved about 200, but if you check here, we have 290 rows, 290 rows, okay? So when you need to see only a specific number of columns in the result set, you indicate the column names separated by comma. Okay. There are times when you may want to give meaningful names to some of the columns, because during the design of the database, particularly when creating tables, you may have to abbreviate names of columns because you do not want to have space or certain symbols as part of your column name. But when displaying the results, you wanted the results to be meaningful to the user. So you can change the actual names that are displayed in the result set by using what are called aliases. Aliases are simply other names that you use instead of the original column names. We'll see at a later stage how you can also have aliases for tables, okay? So an alias is just a different name which you are using to identify columns from a table. So there are a number of ways you can do that. Let me go back to my presentation. Okay, so so you may want, for example, to show department number with space, department name with space, so you can use aliases. Now, there are different approaches you can use to do that. The first one is to indicate the alias in brackets followed by the equal sign, and then the original column name. Okay, that's one approach. So this is the name that is going to be displayed, but the original name in the table is this one. Again, you can have that displayed, but the original name is appearing as that. The second way you can do this is to indicate the alias immediately after the original or the existing column name. So in the second example, we have department ID. That's the name which is in the table, but we want this to be displayed instead. So you can put it immediately after that, but of course you have to put it in quotation marks because it has space in between. The third way is to use the keyword as. So you have the original name, column name, followed by the keyword as, and then the name that you want to be displayed in the results. Okay. So if we go back to Management Studio and execute this, you see that I have the names, department number appearing there and department name appearing there instead of the names which are in the table. Okay. Maybe for comparison's sake, let me just do this. Okay. So you see on top, I have the column names as they appear in the table right now. And below, I have the corresponding names that I've assigned to those respective columns. Okay, so those are aliases. Now, okay. When we say columns, those of you who may have attended the earlier introduction, you recall that in logical data structures, entities are items about which you store information. For example, employee, a book in the library, member in a library, a department in a maybe electronic point of sale or stock control system, a payment maybe in electronic point of sale system. So, or order details, those can be entities. Okay, that is, an entity is something about which you record information, something that is important enough for you to want to store information about it. Now, entities will have certain characteristics, and those are referred to as attributes or properties. So an employee entity will have attributes such as employee name, employee date of birth, maybe salary scale, home address or physical address, position, and so on. Those are some of the characteristics that you can store about an employee. A book in a library system will have characteristics such as a book title, author or authors, subject, a number of pages, year of publication, publisher, and so on. Those are some of the characteristics that you can have about an entity. Now, those are referred to as properties or attributes. When you move from a logical data structure into creating the actual database structure, entities will normally be the ones which are going to be implemented as tables, okay? And those entities, when they are implemented as tables, the attributes or properties are the ones which are going to appear as columns. So do not get confused when we talk about attributes and columns, okay? They refer to the same thing, okay? So now, you can have a select statement where you can display results with a literal value. For example, we have this one where we want to display the word designation. It's going to be, this is called a literal value or a string literal, meaning that this information is static. It's not going to be changing. It's not being retrieved from the table. It's something that we have just assigned, okay? Sometimes you can have literals which are numbers, okay? You want to divide the pay rate by 100. 100 in that case is a literal value, okay? So when you need to display literal strings, all you need to do is to include them in the list of columns to be displayed in the result set, okay? So again, I will go to the in Management Studio. I have that, okay? So in this column, I'm displaying a literal value or a literal string called designation. And I just include it in the list of columns after the select keyword. The next part is the use of concatenation. Concatenation is where you join two or more pieces of information together so that they appear like one, okay? There are times when the results that you retrieve or the results that you show from the database need to be joined. For example, you have a table with first name, last name, and title. You can display the results by connecting these together so that in the results, the user is going to see Mr. John Banda, okay? So to do that, you joined the different values from different columns together using what is called concatenation, okay? In SQL Server, you use the plus sign to concatenate strings together, okay? Of course, when each programming language will have its own symbol that is used. In some programs, they use the ampersand like that. In some programs, they just use a dot, okay? But in SQL, we just use a plus. And when the database says that the items which are being brought together are strings, it's not going to attempt to find the sum. is going to just join them together. Okay. So again, let me just illustrate this by going to SQL Server. So I can say select John, then I say plus, then bundle. So I've joined together these two names to form one, okay? Of course, you notice two things. One, I didn't leave space, so there's no space between the first and the last name. And secondly, there is no column name. You can edit this to correct that. I'll leave space there, or I can leave it as it is and say, so like that. And I want this to be to appear as full name. So that way I've taken care of the need to leave space between the two words as well as the column name. Okay. Okay. When you are performing calculations, you can use these symbols supported by SQL Server. They are very standard. The only one which might not be very familiar is the modulo, this one. Modulo is an operation where you want to return the remainder. You divide two numbers, and instead of showing the result where there is a whole number and a fraction part, you only return the remainder. Okay. The others should be obvious. Again, let me just illustrate with a few examples. So I can say select 10 times 2. So it will give me 20. If I use modulo, the answer is going to be 2, because when you divide, sorry, the answer is going to be 0, because 2 into 10 is going to be 5, remainder 0. Okay. If I have, say, 7 modulo 4, will give me remainder 3. Okay. So these are the mathematical operators that you can use in SQL Server. Now, the where statement is used to specify the rows that should be displayed. Remember, rows are also referred to as records. So there are times when you don't need to retrieve all the rows from a given table. So, for example, in our employee table, we may want to only see this one. We may only want to see maybe employees who are females, okay? Or we may only want to see employees who are single or married. Or we may only want to see employees who are marketing assistants. So you can use the where clause to specify the condition. So you can say select from human resources dot employee and select all the columns, but we want only to see employees who are male. So we say where gender is equal to, okay, we say females. So we say where gender is F. So when we execute that statement, you can see that in this column, and out of 290 rows, we have come out with 84 rows, and all these are females. Okay. Sometimes you may want to see maybe employees who are single. So again, you can change the condition and say marital status equals so in this case, you're only going to see employees who are single. If you need to combine conditions, maybe you only want to see married female employees, then you have to use the word and, then you say gender equals, in this case, we want to see all the employees who are single, I want to say married women, so I'm going to say that. Okay. So if you check here, marital status will be M for married, and all of them are going to be female, and there'll be 49 rows altogether. Now, You can also specify conditions using what might be called relational operators, okay, or comparison operators, less than, greater than, less than or equal to, and so on. So you can use any of these to specify the conditions using the where clause. On top of that, you can use the logical operators which I've already introduced you to, that is or, and not. Okay, so these are some of the ways in which you can retrieve information. I'm afraid my time is up. Any quick question before we are logged out? Any questions?
No questions, sir.
Okay, I'm afraid my time is up. Please go through that and
Yes.
practice. And if you have any questions, as usual, ask and let's discuss on the WhatsApp group forum.